So what is parametric equations? When we have the Cartesian coordinates of some object are expressed through the parameters, often through the time. For example, if we have y equal 3t minus 2, x equal t plus 1. So we have how y and x change with the parameter t. And if you want to find the Cartesian equation which will connect y and x. So we need to solve them simultaneously. We express, for example, time from here. T will be equal, not necessarily time, but often it's time parameter. T equal x minus 1. And we substitute it here, we get y equal 3 times x minus 1 minus 2. So y equal 3x minus 5. So from the parametric equations, we obtain the Cartesian equation relating x and y. Make sense what we did? It's not always that simple, and before going where it's more related to circular functions, I'll give you another example which will be useful for students who will be doing next year physics unit 3-4. Actually this year, because we will do this bit in second semester. Projectile motion. When we have, for example, something thrown at the angle theta to the horizontal, that's yx. And we have that equation describing x and y are x equal, and its initial velocity u, x equal u cos theta t, y equal u sine theta t minus gt squared on 2. That's how the x and y coordinates of the projectile, something that's thrown at the angle at the horizontal, change over the time. How we can obtain the Cartesian equation? We need to eliminate t. We have parameter t. So from here, from the first equation, t equal x divided by u cos theta. And that's equation 1, equation 2, and we substitute t into the equation 2. We get y equal, parameter t, in this case it's time, how positions change over the time, so it's a parameter. Y equal u sine theta times x over u cos theta minus g times t squared x squared over u squared cos squared theta, and that's onto t squared. Simplifying will give us u cancels out, sine over cos is 10, so you get x tan theta. Theta is fixed, it's a number, it's not changing, it's certain angle at which we throw theta. X tan theta minus, here we will have g, so divide by fraction, we have this going down because this is a fraction, so we have minus g x squared over u squared cos squared theta. What kind of relationship is that between y and x? Between y and everything else is just numbers. What kind of relationship between y?
Mr. V, check the 2 out.
Yeah, where's the 2?
Lost 2. So we have 2 here. 2u. What their kind of relationship between y and x?
G gravity.
G, it's all number, yeah.
Parabola.
It will be parabola. It is parabola. It is quadratic, and this will be upright or upside down parabola.
Upside down.
Upside down. So that if means that when you throw something then to the horizontal, it will follow the parabolic path, which equation we can find. So main idea at this stage, when you will be doing that in physics, you will need to we'll do much more with this. But for now, how we obtain the Cartesian equation. We eliminated parameter t. We eliminated parameter t. Now let's consider some more examples which are more related to trigonometry itself. So if we have, for example, x equals 2 cos t, y equal 2 sin t. How we will find the Cartesian equation? How we can relate x and y? Find the equation.
Y equals 10x.
No, not 10x will be y over x will be 10t, but t is a parameter, it changes.
Yeah, but 3 equals x on 2 cos.
To do this, what you say will not eliminate t. We don't want t. We need to get the equation.
X on 2 cos.
Yes, we have t. No, we do not that. We do cos t equals x on 2.
Oh, it's cos t. I thought it was just cos.
Sin t equal y on 2. And then Pythagorean identity. Sine squared plus cos squared equals 1. So because cos squared t plus sine squared t equals 1. So we get x squared on 4 plus y squared on 4 equals 1. Which shape is it?
Ellipse.
No.
Oh,
Times
it's circle.
it's circle. Times by 4. Times by 4. X squared plus y squared equals 4. It's a circle with a radius 2. It's a circle with a radius 2. Makes sense how we found the equation.
Because of the 4.
But it's 4 and 4.
Yeah, I got that.
It's same number. Now we will get equation for ellipse. For ellipse will be, if we have, let's say this is 2 cos t and this is 3 sin t. If number in front of cos and sine is not the same, then we still do the same thing. Cos t equals x on 2, sin t equals y on 3, and still Pythagorean identity, cos squared t plus sine squared t equals 1. The only difference we'll have now y squared over 9, which is, now we have ellipse. Now we have equation of the ellipse, x squared on 4 plus y squared on 9 equals 1. Make sense?
Yeah.
Now, let's another example. Circle ellipse. If we have x equal 2 second t, y equal, let's say 3, y equals 3 10 t. Let's again find what second t equal and what 10 t equal. Second t equal x on 2. We have 10 t equal y on 3. Now, which trigonometrical identity we can use now? Yeah, we have 1 plus 10 squared, 1 plus 10 t squared equals secant squared t. And substituting, we get 1 plus y squared on 9 equal x squared on 4. Rearranging this, we get x squared on 4 minus y squared on 9 equals 1. This is what shape? Hyperbola.
X go minus.
Minus, when it's plus, it's ellipse. When it's minus, it's hyperbola. So in this way, we defined with the parametric equations, we defined the hyperbola. We defined the hyperbola. And that is how you, dealing with the parametric equations, how you find in the Cartesian equation when you have parametric. When you have just something like linear or quadratic equation with a t, you eliminate t. When you have x and y expressed through the trigonometrical function, through circular functions, you need to think which identity you can use. And there are only 2 of them that you might use. One is Pythagorean identity, sine squared plus cos squared equals 1, or this identity, 1 plus tan squared equals secant squared.
Only them two. Only them two.
Okay, could be, what will be 1 plus cotangent squared t? Will be cosecant squared t. Will be cosecant squared t. Okay, that's all what you need to know for now, at least for now, about parametric equations. So like, subscribe and donate to help fight terrorist countries and organizations, Russia, Iran, etc. Support Ukraine and Israel.